What if you could describe cloud architecture in natural language and have it produce a formal design, all of it in code? All right, code that you can use as if you would use application or infrastructure code. Code that you can share and work, collaborate in a team, right? And code that you can maybe later feed into some deployment tools, all right, that work in a code-driven way. I mean, to deploy workloads on a platform of choice. With large language models, that is a realistic option. I'm Avis, customer engineer at Google, based out of Brussels, Belgium. And I'm happy to explore all this with you today. Now let's get started. Right, in this session, we'll start with some core concepts, right, of model-driven architecture and architecture as code, and then we'll take a look at architecture diagrams as a first step in the process, diagrams that can be designed in a code-driven way. And then we'll take a look at the role of generative AI, right, for generating code and diagrams. And we'll take also at some LLM specialization techniques and some learnings and recommendations result of some experimentation done in that area. And then we'll illustrate these concepts by showing a demo at the end. And then we'll wrap up with some final thoughts. So, yeah, let's get started. Now, let's describe, first of all, some known and less known concepts first, okay? I think everybody has heard of model-driven architecture, and OMG, object management group stuff. So what is model-driven architecture? It's, as described here, is an approach to develop systems by producing code based on agnostic, technology agnostic and abstract diagrams. So this is the original description by OMG. And it contains 3 phases in the process. It's the CIM, so the computation-independent model. It's a way of modeling systems by only focusing on functionality, thinking of it in terms of rules and logic, leaving out everything which is implementation and technology, platform-related. And then you have the platform-independent model that refines the previous model with notions like data persistence, transaction management, but still agnostic to platforms and technologies. And then you have the platform-specific model, which does exactly that. Adds these technological components that translate into code that you will be able to deploy on a platform of choice. Now, this definition, although visionary at its time, it hasn't had any traction. I mean, because it's also because it's way too complex, and it's easier said than done to take to transit through these phases, and keeping the right level of abstraction, and being able to deploy things in a technology agnostic way. So it really never, had any huge traction. And in the meantime, we know of many tools and frameworks that have taken a shorter path to automate this thing. So, I don't know, dropping this absolute requirement for abstraction. And then you have something more modern-ish, okay, the architecture code. It's an approach mainly adopted by cloud communities. It is complementary to infrastructure as code, right? Because it assumes that you do a bit more than just infrastructure. You have to take care of your applications and the overall structure and everything. So there are some tools in this area that are giving a try at this concept. And then you have the diagrams as code, all right? A somehow overlooked practice, okay? Diagrams as code is, yeah, it's a formal way to represent diagrams by means of code. And this could be a first step in this architecture as code thing. Now, so let's dive a bit deeper into this code, into visual diagrams. So we'll look at the diagrams library, among other tools of various popularity. It is an open source library that easily expandable, and covers a lot of technologies and platforms. So let's take a look at the diagrams module for Google Cloud. Okay, generally speaking, the diagrams library has got core concepts, starting with diagrams. That's the main class, object type, okay, that's to create a diagram. And then you have nodes, which is the class for system components, services. And then you have cluster. The cluster object type allows you to group and cluster services that belong together, to isolate them. And lastly, the edge, or the relationship between the nodes. As you see in this diagram, this is a data pipeline, streaming pipeline in Google Cloud. You see the diagram, you see the clusters, all right, the event data producers, the data ingestion cluster, and in every cluster you have Google Cloud service components like BigQuery for data analytics, Vertex for AI ML, and Looker Studio for data visualization. Let's look at another example, like this embedded cluster concept. So you have a multi-regional deployment of resources and then subdivided into zones. You can see very clearly how these clusters are grouped and isolated. The thing is that you don't only see components, you also see the information flow, right? Going from one component to the other. So, what is it like working with a library like this? Okay, let's start with the advantages first. First of all is the formal notation, okay, of expressing architecture in code. I mean, it guarantees consistency. You don't have any surprises. There's only one way, I mean, to do that in code. The code can be tracked, versioned, managed, and shared as any other application code. And that makes it very easy to work in teams, okay? It's not that you need anything more but an ID to do that. No fancy tools. You just, yeah. And because it's done in a code-driven way, it's easy to, at a later stage, to take that code and plug it into something else. I mean, that takes code and deploys that into production, into a platform of choice. And then, but there's a but. I mean, it's not that easy to work with such a library. First of all, manual coding diagrams, I mean, especially complex ones, I mean, it's not fun because it's not, you know, it's not visually centric, and it's hard when we're building diagrams to try to visualize what you're building. I mean, it's counterintuitive, and sometimes, yeah, visual diagramming can be faster. Just pen and paper and just. So the thing is that you'll also have to learn a specific syntax of the library and keep the library up to date and your knowledge too and everything. And if you want to collaborate with people who are not using IDs and Python in this case every day, well, it can be a bit tricky, okay? So the question is there anything that you can do, or AI or Gen AI can do, I mean, to keep hold these advantages, and yet being able to move faster and ease collaboration? So let's look at what generative AI could mean for diagram and code generation. Now, let's start with Gen AI creating diagrams directly from prompt. Okay. Thing is, with pre-trained models out there, will normally and by default give you only text-based diagrams. Okay. Sometimes they will not give you anything. Sometimes it will just resort to some kind of verbose explanation of the solution architecture. Okay. So what you see right there is like the output to some queries like, yeah, show me this and show me that, show me a diagram of that architecture. So, and that's what you get. Okay. The thing is that there are some good reasons for you to get that kind of output. Okay. First of all, diagrams often invoke complex concepts like relationship and space and flow and constraints. It is very hard for generative AI, for an LLM, to know the intricacies of enterprise architectures and networking and security without being specialized. I mean, a specialized training on it. And then things which are not explicitly mentioned in a user's query, it is very hard for an LLM to deduce that ambiguity, all right, and translate it into exact code that runs and compiles and creates a diagram. So that's not gonna. And then, yeah, because of that also, it's very hard for LLMs to really grasp content because they cannot just deal with that ambiguity and translate it into something formal. On the other hand, if we look at code generation from an LLM, we're talking then about a much more advanced thing than creating diagrams. First of all, code structure is formal. Okay, so you have a strict syntax and you have rules, this well-defined structure. I mean, it makes it easier for AI models to learn patterns, learn style, be able to tell what's coming next, all right? Second, there's an enormous amount of training, of open source code out there. I mean, and this is what has made, LLMs be very, very proficient in specializing in code generation. As we said, code focuses on logic and functionality, not into visualization. And because of this, it is also easier for LLMs who are text-driven. And with that comes measuring the success of generated code. If you know the syntax and if you know the rules, it can be also very easy to objectively evaluate if something is correct. It needs to compile, it needs to run. Okay. For diagrams, there's more subjective kind of decisions. I mean, it always relies on human judgment. And then, the major focus that it has, Gen AI has known, I mean, for the last years now, code, generating code, chatting with code, completing code completion has been, I mean, there has been a huge investment in this area. So is there a way then to put all this to use by using generative AI as a code generation engine and then having the code will generate the visuals for us. So we will have the Gen AI focus on syntax and semantics, and then have another tool, create that visualization for us. So in the context of the diagrams library, means like having the user express the description of what they want to do in natural language. All right. Have the LLM generate the code which has been trained on pass the code back to the workflow, to the application, and then have the diagrams library invoked with that validated snippet of code, generate a diagram, and pass it back to the user. Again, it is not a matter of generating code. Everybody is, I guess, here has been experimenting with code generation tools, but if you want to use it to build diagrams formally, then there are some additional requirements with regard to that. I mean, for it to be called a successful attempt. So it is a bit harder because one thing is to mention a specific service that you want to build a diagram for, or an ambiguous description of what that service is supposed to do. So there's a difference between saying, give me spanner in this diagram, okay, or Cloud SQL, or just give me a global database. So the success of a model relies very much on its ability to cope with this ambiguity. Now, let's check what techniques we have at our disposal to train an LLM to understand, to train it on specific code and to be able to generate code that you can use to use it to generate diagrams. Well, first of all, it's fine-tuning. It's adapting a pre-trained model on a specific code library. Means creating a lot of samples with code and description and some additional data, which you will have to pack into a data set and a curated data set that it can be used by the model. I mean, this can take a lot of time to achieve. Then you have the contextual control, while using prompts, conditions, preconditions, rules, guidelines, by means of context windows. And then you have RAG, using, in this context, the diagrams code base, chunking it in pieces and vectorizing it. All right. So it can search and ground its answers while generating code, and of course a combination of these three techniques. So with the diagrams library, I use these three techniques. The largest window below, it's what I use for the tuning part. So I created a data set of nearly 100 architectural blueprints, okay, containing code, description of code, and I used it to tune models which were fine-tunable. Not every model, I mean, that's out there, I mean, allows fine-tuning. So I did this specifically for Google's Bison code family, for code generation and code chatting. I have to say this was a very, very long process. First of all, I was not able to create sufficient samples, I mean, to cover everything. And then you'll need to organize and format that information to data sets and then feed it. And then, from a cost perspective, this was by far the most expensive thing that you could do. And can you imagine every time you change the code base, you will have to do it again and again? So that's very, can be very expensive. For RAG, it's on the top left, you'll see, well, that's the complete source code. of diagrams library only for Google Cloud, all right? There was like 3,000 lines of code, more or less, okay? So it was chunked and vectorized, be it in memory, okay? There's no need to have a store. And once you do it, it's very easy to replicate through models and everything, once you program that logic and everything. So that's not that much work involved. However, if the code base is larger and you have additional requirements, heavier requirements, then you might want to use a vector store and knowledge graph, which can add more features and functionality, but more complexity as well. And the context windows, that's the far right, the right window on the top of the screen. Yeah, I passed every rule, possible rule that you can think of, conditions, preconditions, and yeah, depending on how models, okay, not in very different ways for different models, because it very much depends on how models, accept context, and it also depends on whether the models are support multi-prompting. And there were some key findings from it. Yeah, Genie was the name of the demo that we're going to be showing. So, as I said, not every model supports fine-tuning, okay, and reinforcement learning and distillation. So you are very limited in the tools that you can use. You're left with context and RAG, and that's it, okay? You cannot use, for example, interactive refinement of a model, okay, based on user input or self-correction of the model. Now, fine-tuning. Fine-tuning itself had challenges. I had challenges with overfitting, okay? And you will see then from when we show the demo that the tuned models show diagrams which are simpler in style. And this brings us also to another problem. We say overfitting, but in order to have a model to go beyond those data that you have trained it on, you'll have to provide a myriad of combinations of data, complex architectures, which is not feasible. So, and again, like I said, tuning, it is the last resort in this case. It will cost you a lot and not add very much value. RAG too, okay? It can retrieve relevant code snippets, okay? For those basic scenarios which it can understand, but when it comes to being creative and being asked to create complex solutions, well then, it is not what you're gonna get. Okay, it is like fine-tuning. RAG works with replicating what it already knows. Okay, it does not have much of creativity when it comes to providing you better solutions. And then we have context. Context windows have a different set of challenges. Okay, the problem is for you to know what to pass with context, because it is, especially with larger context windows, it's very, very, very hard to introduce irrelevant or noisy information, and then the model loses it. It cannot well decide what's relevant, what's irrelevant, what's important, what's not important. So, and this can very negatively impact the quality of code you get. Now, let us show something here with demo. Let me log on. So I'm going to start showing, we'll start interacting with these models. I mean, we'll start interacting with the pre-trained models first. So just to illustrate what we said at the very beginning, if I would ask it, for example, I'm querying the Bison, the Cody version of code chat. If I would say, for example, show me a diagram of a typical 3-tier web app. Yeah, this is what it gives you. If I copy paste it. And do it with Gemini 1.0. This is what's going to give you. And the code gen. This is where we're taking off from. Now, let's start with the tuned models, okay? If we take the code chat, Cody, of the Bison, Google's Bison family of models, and just do the same thing. I'll paste. Now, this is what it gives. If we look at what it has created, so that's what it has done, what we described. So it has gone on generating the code, validating the code, compiling the code, and using the code to generate the diagram. So you have two artifacts here. You have code generated, and you have the diagram generated. And because it is a code chatting model, you can interact with it, actually. So if we ask it, for example, to add some new component, so I'm asking it to add a web security component for the front end. So you see it has added the web security scanner. See it? Imported from the correct library. Now, we didn't get it now, but there's a chance that I can try, give me a multi, show me, of a multi-regional GKE deployment with a global load balancer in front. So I don't have to type this again and again. So this is the typical example of a tuned model. Now, if you change code, it keeps referring to things that has been trained on. for me to solve this problem means to go and retune that model. So go and pay like hundreds of. It's not a given, okay? The code generation has been trained, has had an earlier tuning, fine tuning than the code chat model, and the code chat model can cope with that request. The gen model not, because of the staleness of the training data it has been tuned on. Now, we can give RAG a try. I have some. Is there any query that you want me to pass to Genie or whatever? Hmm?
Like a web API and a database.
Okay.
Let's add a storage component afterwards.
Okay. So you show me the diagram of an application with an API, you say?
Yeah, like web front-end API.
With an API. Data storage, you said. And what else? And the front. And the front. Okay. Yeah. Hold on a second. I need to configure the rack parameters. Okay. So I will not touch. Huh. So yes, but is it exactly what you asked for? Yeah. Yeah? Okay, I'm a bit surprised. Why? Because I said, I mean, RAG is not that intelligent when creating. I mean, when it comes to being creative. All right, it kind of replicates. Now, if I were to ask a more complex question, then you'd see it how it would behave. So let me try this one. Show me. Do we have to show me a reference architecture diagram for what? For a retail media streaming application. Is that good? It's very vague, but it's asking for a reference architecture, so. Oh, okay. Let me copy paste this. I can use it somewhere else too. So what it has done, so it has created the diagram, the cluster, the streaming service, the data processing service, the data storage, data. It looks good. Okay. So this is code that you can just let me test this. So I'm copying the code and let me test directly in the library. I mean, if it. So this is the library. If I do this, yeah, it parses it correctly. Yeah. So, okay. But then I'd like to take this and feed it to, hopefully, so I'll just disable RAG. I'm going to try this. But this is experimental, so if it throws up things that shouldn't be, so you're warned. I mean, it's like. So show me the reference architecture diagram for a media streaming application. Shall I hit enter? Did I just refresh it unwillingly? Okay, let me try again. It means it's thinking hard. All right, but this is really good. Can you see it or not? So, media streaming. So you got the media processing cluster, serverless, as it comes in. It's being stored to object storage. Streaming being processed on Google Kubernetes Enterprise. Okay, load balanced. And then pops up in analytics and monitor. Well, it looks good, but if we do it differently, if we're to ask Gemini what this means, explains the diagram. Then it would be better to get the answer from. So we'll reverse, like, let me. So we're having Gemini create it for us, and we're asking why, what has created, and okay, that's quite verbose. We don't have to go and read all that, but does it make any sense? So it's describing what the components are. The load balancer, the streaming services, exactly. The media processing part, the functions, so using serverless, as we say. Storage, okay, stores media files, also very good. It is a reference architecture, actually, okay. Database, Firestore, and NoSQL data for storing application data. Yes, exactly, you would store it there. And then for the data management, for master data, accounting, billing, and relational data, okay, that's also fine. Analytics, BigQuery. It explains the data flows as well. So just with a simple query, you can create system documentation. You have the diagrams, and you, you have it all explained. Can we, another query for 1.5 for the Gemini? Yes, sure.
Why did it use this diagrams library? Why did the Gemini 1.5 model use the diagrams library?
No, the application is using. Gemini is not using the library. The Genie is using the application. So if you remember what I said, we are using Gemini to generate code. We are training it, but I'm fetching the code from Gemini. I'm validating it. I mean, Genie is validating, the application is validating it, and it's passing it as a parameter to the diagrams library. So it's not Gemini who's giving you the diagram.
Is Gemini calling the library?
No, it's a service call in this application which is performing it, but it's using Gemini's output because I have to go and parse, because you can get a lot of other things with code, all right? So I'm parsing it, and I'm just validating it. I'm taking the code, and I'm passing the code to the diagrams library, and this is what you get. So do you want me, before we call it, is there any query that we would like to have this app crash with? Yeah, Don?
I would be interested in seeing like a very specific query, kind of like too specific.
That's a good question, because I had but I'm not going to type that. And I mean, it's like, it takes a lot of time. So, hold on. Is this specific enough? Okay. Do you want me to read it? No, you just read it yourself. I mean, yeah? Okay, I'm going to throw it there. Oh my God, you see? Yeah, why did I, okay, there's a small bug in here because if I refresh what I just did, the diagram disappears. But look at the code, so we can fetch the code, and so it's quite complex. I mean, you wanted to write it yourself, so let me do this. Yeah. So this was the code it generated. Let me do this. So disaster recovery plan. So you have the primary and secondary region, okay? You have cloud monitoring, outage events. Well, that's great, feeding them in there, the failover function. And then it load balanced through traffic director. It's incredible. So it's like, it's active, like, okay, yeah. It's more than disaster recovery. It's just like, yeah, it's, but that's, yeah.
Have you tried to translate Terraform into a diagram?
Who?
Have you tried to translate a Terraform configuration?
No, but that was supposed to be my closing remarks, actually, because that is a very good idea, what you're just saying, going from here to Terraform. It's formal, this is formal, that's formal, so you can complete the whole cycle. From diagrams to deployment, you see? I mean, those notions and descriptions at the very beginning, it kind of, yeah, leads you into this direction. So, yeah. Now, so let's close the demo. It did, now, so you saw it. I mean, but it can really get better than this. Okay? I have spent time with building rules and preconditions and postconditions, pay attention to this, to imports and to the object names, cases, and whatever. A myriad of problems and troubles that LLMs have with those kind of rules and directions and conditions. So how can that be done in a different way? In my opinion, you should let the LLM handle these complex patterns. You saw Gemini 1.5 is just great. It's just great. You don't need no tune. I mean, no, you don't need tuning. You don't need rags. You don't need anything just by using context. But still, is it sufficient? No, because when it comes to code, okay, the LLM can handle these complex patterns and generate code and everything. But you need a rule-based system to ensure adherence to syntax and best practices and style. So this is what you can plug in, a rule-based system for syntax checks and I don't know, and any other rules that you want to, and there's tools out there. You don't have to reinvent the wheel. You just plug it in the flow. Second, interactive refinement means getting user feedback as you work with it, okay? And make the model better. I mean, the model needs to support that kind of and the models I worked with, they don't, I mean, as we speak currently, they don't support it. And then you have the whole reinforcement learning. Okay, have the model itself penalize errors and reward good behavior, okay? Self-calibrate. So these will, yeah, these are the ways, I mean, the things to do to get it better. And to close, the gap, what you were talking about, I mean, this architecture as code, diagrams and whatever, and deployment, Polomy, Terraform, there's other tools as well. It's a matter of creating this missing link, like building a plugin, whatever. And then you can, yeah, you can it's not very far away or it's not too far-fetched, actually, I mean, to think of that being realized. And with that said, let's close. Thank you very, very much for being here today.